Today we're going to take a look at section 2.5, Factoring Polynomials. It's a continuation of what we did last time. When we're factoring these polynomials in particular, we are looking for what happens when I have a values that are not equal to 1. So, first thing we do is we look for any factors that they might have in common and factor those out. And then the second thing that we're going to do is we're going to either continue at that point with trial and error or with the AC method. The AC method is sort of a surefire way. Trial and error is a little more difficult when you don't actually have an a value of 1. So let's take a look. On the first one, what do you notice that they all have in common? 5. Very good. It's like you've never seen this before. All right, so if I factor out the 5, I have y squared, and then what?
Minus 9y.
Yeah, minus 9y and plus 18. Awesome. Okay, we're back where we were before when it comped out on us. Okay, so on this one, we actually end up with an a value that's 1. So everything I do from here forward is going to look and feel just like the last section. We just had that sort of extra step at the beginning where I factored the 5 out. So let's do the AC method on this. And again, if you can do a trial and error, that's fine. A times c would be 1 times my 18 to give me 18. And my b value is my negative 9. I don't think I've actually done one where I ended with a positive 18 and then a negative 9 yet with you guys. So this is a good one for us to look at. I need two numbers that multiply to give me 18. So I have 1 and 18. What else do I have?
9 and 2.
9 and 2. What else?
6 and 3.
6 and 3. Anything else? I think that's it.
1 and 18.
I already got 1 and 18. Yep. Okay. Now, both of the signs are going to be the same. Otherwise, I wouldn't get a positive 18. In particular, they both have to be negative, or I'm not going to get a negative 9 in the middle. So I'm going to essentially go back and put a negative on all of these. Which two
6.
add to negative 9? The 6 and the 3. Okay? So I'm going to shift this up actually. I've got my 5 here. Whoops. And then now I've got my y squared stays the same. I've got negative 6y and negative 3y. And then I've got my positive 18. Okay, is that all right for everybody so far? AC method just with a 5 in front. Lovely. So we've got the same 5. We're going to group them. Y squared minus 6y, what do they have in common?
Y.
A y. If I pull out the y, what am I left with? Y minus 6. Fabulous. Now, I've got my next one. Negative 3y and positive 18. They have a 3, and I actually have to pull out the negative with it. Why? Yeah, because on the inside, the signs have to match. I need a positive y. If I didn't pull the negative out, I'd have a negative y. And I need a negative 6. If I didn't pull the negative out, I'd have a positive 6. My signs would not match. But they do now. So the 5 keeps getting written down. The part they have in common is y minus 6. And what remains is y minus 3.
So that's all. We don't put the 5 back in.
No, it's factored. Your goal is to have it in as broken down of pieces as possible so the 5 stays on the outside broken out. Yes.
So whenever I was doing this in high school, my teacher taught me a method called slide and divide.
Yeah, we're not doing slide and divide.
We're not?
Mm-mm.
Can
I'm
we
sorry.
with these if we wanted to?
You can, but I'm going to tell you that if you make errors, the grader's not going to give you partial credit for the errors which you make because that's not the method that I'm going to describe.
Okay.
So at your own risk. All right. Okay, let me show you then what would happen if you tried to do this one maybe with trial and error. All right. So does everybody have everything written down that they'd like from here? Because I'm going to erase a bit so that I have some space. We're good? Okay, I'm going to go back to what we had before, or right after we divided out or factored out the 5. Okay, so the first step's the same. You pull out the 5. All right, and then it'll look just like what we did in the last section. I have 2 sets of parentheses. Y has to go in the first pieces, right? And then at the end, I need two numbers again, or actually I need two signs that match. They both have to be negatives, so I can do my negatives and negative like by default. And then again, I need two numbers that multiply to 18 and add to 9. They're 6 and 3. Okay, so the trial and error part when I have a coefficient of 1 is not too bad. It's going to be harder in a minute when I don't. Any questions on this one before I move on? All right, number 2. Greatest common factor.
No.
Just a 1, right? Doesn't help me. So I don't have the ability to pull that 3 out and all of a sudden, hey, look, there's a coefficient of 1. I don't have that. Not with what the methods are that I'm showing you anyway, right? So we're going to deal with it from scratch. I'm going to show you the AC method first because I think it becomes a lot more attractive of an option when I have a coefficient that's not 1. So A is 3 and C is 8. So 3 times 8 is 24. B in the middle is negative 14. Okay, so if you'll notice, there is not a 24 in this problem, is there? There isn't. That's something new. I didn't have that happen on the earlier problems. So when I have a 24 here now, I'm going to do the same as I did before, write down factors of 24. So I have 1 and 24, 2 and 12 or 12 and 2, 8 and 3 or 3 and 8, 4 and 6 or 6 and 4. 24, I don't want to say it's a terrible number because that's sort of unfair, but it's at least a messier number because it's got lots of factors. Can't seem to grab it all and move it. All right, cool. All right, now the signs have to match, otherwise I wouldn't get a positive 24, and I am supposed to get a positive 24 here, right? So they either need to be both positive or both negative, and this determines which? Negatives. So if you think about going up here and shifting all these, they're all negative now. So I actually have negative 1, negative 24, negative 2, negative 12, negative 3, negative 8, negative 4, negative 6. That's what I really have. I need two of them that add to 14. That's 2 and 12. This is my pair. Okay, so let's go back to my original equation. And in the middle, again, it doesn't matter the order that I put them in, so I'll just put them in the order I already have them. It's negative 2x, negative 12x, and then positive 8. Okay, notice there's no 24 anymore here, right? I used the 24 to figure out the 2 and the 12, but I'm using the original equation that had an 8 at the end when I rewrite the pieces in the middle. All right, 2 at a time. 3x squared and negative 2x, what do they have in common? X. And I pull it out and I get?
X minus 2.
I have 3x minus 2. Okay, cool. Next two. That's not a good color. How about yellow? Negative 12x and positive 8. 4. And I need it to be negative so that my signs will match on the inside. Right? I need the middle piece to be negative and the first piece to be positive because that's what the first parenthesis has. So I need to pull out a negative 4. So what is negative 12x divided by negative 4? 3x. That's good because it matches the other parenthesis, right? Yep. 8 divided by negative 4? Negative 2, and that matches the rest of the parenthesis. Okay, so looking at these now, the 3x minus 2s, those have in common. So I have 3x minus 2. What's left? X minus 4. All right, confession. Everything I did with the AC method in the previous section, I would have never, ever done if this weren't so nice. Because I think trial and error, when it has a coefficient of 1, is pretty easy. It looks pretty similar to what happens with the AC method with a lot less work. But the AC method here is really nice. Because I want to show you what happens on this problem if you don't have the AC method and you're using trial and error instead. Okay, I just want to show you. Some of you are still like, I'm still using trial and error. I don't like this AC stuff. I know it. Some of you are. That's what I would have been like if I got to college. And I was like, I learned that one in high school and I thought it was fine. I'm just going to keep using that. So I want to show you the trial and error method. Okay, does anybody else need me to stop for a second? Because I don't want to erase because I'm going to. Okay, so I'm going to erase what we did on this problem. If you use trial and error means putting the parentheses in immediately. Okay, that's what it means. And it means asking yourself the question, 3x squared, how do I get it? Well, there's actually only 3x and x that make that happen. So that's not too bad on this problem. That is my only option. The other thing that makes this problem kind of nice is that I know that the signs have to match, otherwise I won't get a positive at the end. And I know that they have to be negative, so I get the negatives happening in the middle for free. It's harder when one's negative and one's positive because then I have to pick. Do I put negative first and positive second, or positive first and negative second? More options. Every time there's more options, the problem becomes more difficult. Now, on this one, I knew that I had my signs negative. But I need two numbers that multiply to give me 8. Well, I only have 1 and 8 and 2 and 4. So again, there are only two options. That's not bad. It's the first time I've had to make a choice, though. I have to decide, do I use 1 and 8 or do I use 2 and 4? So let's just say you used 1 and 8. Because you have to do a trial and then see if it actually worked. So you pick 1 and 8. Well, the way you decide that it actually gave you the 14 in the middle is that you multiply the 2 in the middle together. That's negative 1x. Can you see that blue on the blue? Okay. It's pretty close to color, but I don't know. And you multiply the outside 2 together. 3x and negative 8. That's negative 24x. And then you add these two. And you say, hey, look, negative 24x and negative 1x. That's not negative 14. Was it 14 in the middle? Yeah. That's not negative 14. So what that means is that the numbers were wrong. But I might have just chosen them wrong in the wrong places. So now I can switch them and go 8 and 1 here, and we try again. All right. Well, negative 8 times x would be negative 8x. And 3 times negative 1 would be negative 3x. And I do it again. I say negative 8 plus negative 3, and I get negative what? I get negative 11. It's not 14, right? So that one doesn't work. So now I'm back to the drawing board. 8 and 1 were not the right numbers. So what do I use next? 2 and 4. Okay, so actually I don't know. I have 50-50 shot, right? One of them's right, one of them's wrong. So in the middle, negative 2x, or negative 2 times x is negative 2x. On the outside, negative 3 and negative 4 is negative 12. Negative 2 plus negative 12 is my negative 14.
Seems like a lot more brain
And
power
there you go.
just using that.
I'm telling you, I think the AC method's really good when the A value is not a 1.
Yeah, I would just use these.
Okay, so, but I wanted you to see it, and I'll show it to you again at least one more time somewhere today, what it would look like with trial and error. This one was actually a very friendly one. The reason it was friendly is because 3 times 1 is 3, and that's the only thing that will work. If the number at the beginning had been a 4, you would have had 1 times 4 or 2 times 2. Two options. It's also friendly because the signs had to match. They both had to be negative. If the signs were different, one were positive and one were negative, you have more choices. Do you do positive and negative, or do you negative and positive? The only thing that we had variability with here was the ending number 8. And yet we still tried 3 things before we hit on the right one. Okay? So that's sort of the problem with trial and error, is that you may end up having to try several things before it works. Let's try another one. So, nobody's like vocally saying trial and error, that's for me. So I'm going to start with AC method. A is what? 7. C is what? Negative 2, which gives me negative 14. It's actually a really friendly number because it doesn't have a lot of factors. What's B?
Negative 5.
Negative 5. All right. So what two numbers give me 14? 7 and 2? Or 1 and 14? Now, it's a negative 14, which means one of them needs to be negative. And I need to get a negative 5 when I add them together. Okay, so I need -7 and +2. That's what's going to work. Okay? If you pick the right combination, it has to work. So what does that mean? Well, it means that if it doesn't, then you've got an error somewhere in your work. But the error is not with choosing -7 and 2. The error is with the undistributing or factoring things out or something like that. So it gives you some sort of insight into where you might have made a mistake. So we are going to take our equation and we're going to rewrite it. I have 7x squared. I have -7x and +2x. Okay, you could do +2x and -7x. It wouldn't be wrong. It would just be the opposite ordering, and it would be okay. And in the end, I have -2. So what comes out of the 7x squared and the -7x? Yeah, 7x. What am I left with? Ooh, good. X minus 1. What comes out of the 2x and the -2? Yep, a 2. And it's positive, right? Because that will give me the same x minus 1. We have x minus 1 in common. What are the remaining pieces? 7x plus 2.
Yeah, we did it. X minus 1.
Oh, I'm sorry, I have a typo. I just wrote it wrong. You're right. It's supposed to be x minus 1, then 7x minus 2, or plus 2. Sorry. So sorry.
Sorry,
Yeah.
The second one is 7x plus 2 because they're in the front of both the.
Yes, exactly. It's these pieces from here.
Okay.
Yes, indeed. Let's try it again. AC. Okay.
Did we
Let me just-
number 2?
No, we did 2.
Oh,
Over here.
I did it at the bottom instead of the top.
Okay.
I did it right here instead of right there.
Okay. Let me actually make one comment before we go through AC method for number 4. It's really not that nice to have a negative in front of everything.
Yeah.
So my advice when you have a negative in front of your squared term is to at least factor out the negative. Now 3, 4, and 4 don't have any other common factors, but I would at very least pull out a -1 and change your signs. W squared, sorry, that's wrong. 3w squared, positive 4w, and -4. It's not going to be wrong if you do it the other way. It's just going to make things really weird looking. Kayla?
I was gonna say if it's okay if we just leave it how it is.
It is. You're thinking it has a little bit weird factoring going on here in a minute. So you may look at this later and decide that that wasn't worth it, but you could decide that on your own if you'd like. It won't not work. It'll just work a little bit funny. Okay. So if you do the AC method, no matter how you do it, whether you left the negative in there or pulled the negative out, when you multiply the 3 and the -4, you're still going to get -12. Agreed?
Yes.
The original AC value or this other AC value. The difference will be the B. If you factor out the negative, like on my screen, you get a +4. If you didn't factor it out, you have a -4. It's the only difference right now. All right, 12. 12 is not the worst number ever. Actually, 24 is not either, but it was not so friendly. I need numbers that multiply to 12.
3 and 4,
1, 12, I'm sorry, 3 and 4, and
6 and 2.
2 and 6. Okay, so let's examine the signs. I'm supposed to be getting a -12 at the end. So that means my signs are what?
Positive 6, -1.
Okay, so 1 positive, 1 negative. Agreed? And they need to combine to give me a 4. So, Maxwell, you tried to tell me which they were. What do you have?
Positive 6 and -2.
Positive 6 and -2. Will those add to positive 4? Yes. So, Kayla, on yours are switched. Okay, Haley,
The way she did it too. And
if you pulled it out, you've got switched signs for me right now, which is okay. Just be aware. Okay, cool. Okay, so we are ready to take our equation. I'm going to leave my -1 out in front since I pulled my negative out. I'm going to leave my 3w squared. And now I have -2w, positive 6w, and -4. Okay, 3w squared and 2w, what do they have in common? They have a w. And if I take a w out, I'm left with 3w minus 2. So that's probably the point where I would take out a -w if I were doing yours.
I
because you've got your negative still embedded in there. That's okay. That's still right. Yeah. Okay. The last two now, 6w and -4. A 2, and it's a positive 2. So I'm taking out that positive 2, and I have 3w minus 2 left. Okay, so I know I'm on top of my bubbles now, but can we still see it okay? Okay. Now, from mine, I still have that -1 out in front. I'm going to put it in parentheses like that just to remind ourselves. Actually, let me do this. What matches? The 3w minus 2. And then the other piece that's left is w plus 2. So I'm going to guess, Haley and Kayla, when you did yours, you're leaving this now with either what I have, depending on how you did it, or you may have 2 minus 3w, and either 2 plus w or w plus 2. Yep, that's fine. Mm-hmm. Okay, sounds right.
So they should, if you leave the negative in it, you're gonna get both of them being addition, right?
You won't get the both being addition. You would get like this. Or another version of it might be that you got it to look like this. Those are the 3 different possible answers depending on how you do it.
And if we left it like the -3w plus 2 and the w plus 2, would that be like a right answer?
Yeah, that's okay. It would be. All right, I don't have any more with weird ones in the beginning, negatives at the beginning, I mean, so we don't have to do that again. All right, so we're going to go back and we're going to try, I already did, oh, I even had a space for it. Look at that. Go back and try number 2 and number 3 with the AC method. Whoops. I guess I just didn't look at any of my directions. I apologize. All right, so just mark out AC right now and just say trial and error, since I can't follow my own directions. I was just so excited about the AC method I had to show you. Okay, we already did this one both ways, so I'm not going to do it again. But let me do number 3 with trial and error so you can see what it would look like, okay? So, start with parentheses. There's only 2 ways to get, there's only one way to get 7x squared. 7x and x. Okay? It's actually not too unfriendly because I only have one option here. The next part's not exactly super friendly, and it's because I have a negative here, means I have one negative sign and one positive sign, and I just have to put them in and see what happens. The other thing that's not too unfriendly here is that the 2 at the end can only be achieved by multiplying 1 and 2 together. So this is one option, 1 and 2. Another option would be 2 and 1. So I'll do that in a moment. We'll just do 1 and 2. All right, so let's check and see. We have to do the check step, right? We do the inside and we do the outside. So the inside is -1x. The outside is 14x. And the question is whether or not it gives me -5x in the middle. And it didn't. So there's only 2 decisions we made. We made one decision where we put the positive and the negative, and we made one decision where we put the 1 and the 2. I need to change one of those things. Do you want to change the signs or change the numbers? Just pick one.
Oh, change the numbers.
Change the numbers, all right. If we change the numbers, so this 1 and this 2 switch, now I've got a 2 and a 1, okay? So if I change the numbers, I've got -2x now, and I have +7x. Does that give me the number I'm supposed to have in the middle? No, but it's real close. What's wrong? The signs are wrong now, right? I mean, like, I'm getting the 5. I'm getting a 5x. I'm just not getting it with the right signs. So when that happens, what that means is that my signs are actually wrong. I need to change them. And if I change my signs, now I will end up with a positive 2 and a negative 7, and I have my negative 5. In your homework, there are absolutely no directions that tell you what method to use. AC method or trial and error are both methods that the grader will have like support for, basically, like written down in her keys. If you use slide and divide, like Maxwell is so intent upon using, I feel like, you're on your own, okay? Because there's no partial credit I'm going to be asking her to look for on that. All right. There's a couple things that I want to mention in this section that I haven't yet, and that's special factoring forms. There are two types of special factoring forms that we're going to take a look at. One is the perfect square trinomial, and the other one is difference of squares. Perfect square trinomial, I'm mentioning it simply because it's there, and you should be aware of it. But if you don't ever notice it, it's okay, because everything we did with the AC method and slide and trial and error work for perfect square trinomials, and you sort of don't even need this information to be able to process it. Difference of squares, you do need it. So perfect square trinomial says the following. If you have a plus b squared, it will always, I shouldn't say it that way. This is the same as a plus b times a plus b. It's a special factoring. And it always happens when we have a squared plus 2ab plus b squared. So in essence, what you really need is you need to be able to recognize, hey, look, it has the form a squared plus 2ab plus b squared. Therefore, I can go back and factor it in this perfect way. I don't know, but I don't notice those things usually. That's a very specific description of something that I could probably figure out on my own every time I needed it without a whole lot of extra work anyway. But it's there, okay? So I'll show you where it happens in the examples I have. The second one, though, is really important. The second one happens when we absolutely have the same multiplication factors, but the signs are different in the middle. And what happens is that we end up with polynomials that look like this. They're binomials. They're missing a middle term. They just aren't there. Now, you've actually seen this happen before in your very favorite section back in Unit 1. Oddly enough, that's the section I taught in the class right before you guys today. You saw it with conjugates. Do you remember conjugates? Same pieces, opposite signs. Okay, use that with radicals. We're not doing radicals, okay? Don't freak out. We're not doing radicals. But you saw it, and it ended up having the same form, but the signs were different in the middle. And when we did that, we noticed that these inner and these outer terms added to 0, and they canceled out. Well, we're using that fact, and we're going backwards. That's all this is, with no radicals. Okay? So, let me show you how this works with a few examples. If you notice these, they're super friendly and they make factoring very nice. Now, on the first one, if you happen to notice that this is something squared, okay, yeah, it's u squared, right? Of course. 81 has a very nice form. What is it? 9 times 9. It's 9 squared. This is u squared, this is 9 squared, and notice in the middle, it's 2 times 9 times u. Okay, so I'm just showing you how to recognize it. If you don't want to recognize this and you want to use trial and error, you want to use AC, more power to you, it's no problem, okay? But this is a perfect square trinomial. The first piece is squared, the last piece is squared, and the middle piece is 2 times their product. So what that means is that this actually can factor as u plus 9 times u plus 9. That's perfect square trinomial factoring, which can similarly be achieved by trial and error or by the AC method. Okay, you don't get a choice on number 6 though. Number 6 doesn't have an AC method. You could use trial and error if you wish, but the trial and error is going to lead you right back into difference of squares. it's a difference. Difference means subtraction of two things that are being squared. This is one of those, like, the name is exactly what it should be. It's a difference of squares. Okay, well, what's being squared? Well, the first one's 5 that's being squared. The second one is the W that's being squared. Everybody with me? Therefore, it factors as 5 minus W, 5 plus W.
So how did you know that it's like 5 minus W and 5 plus W?
Because it's a difference of squares. The difference of squares happens when the first piece is squared and the last piece is squared, and it's subtraction in between.
Okay.
Now, notice, Haley, it does have to be subtraction in between. There is no sum of squares formula. It doesn't exist.
Okay.
But we do have the difference of squares formula. Number 7. It's a binomial, right? Binomial means it has two terms. It's not 3 or 4. So, kind of don't have a lot of choices. It's going to have to be a difference of squares if it's going to work at all, because I don't have another place to go. What here is being squared? 5 and y, right? They're both being squared. 5 squared is 25, y squared is y squared. What's being squared to get 49? 7. So this is 5y minus 7, 5y plus 7. Differences of squares are very friendly. Very quick. Because what you're really doing with them is kind of like trial and error, because you've noticed that they have this very special relationship. All right, 8 and 9 are a little different. You guys ready? Our last two for the day.
Oh,
All right,
oh,
they're not as bad as they look, promise. Go back to the very first bit of information in this section of material, this lesson. We need to find a greatest common factor. What is their greatest common factor?
3 to the 5th.
3 and u to the 5th. Okay, is everybody good with that?
Yeah.
3 and a u to the 5th. So if I take 3 u to the 5th out of u to the 7th, what do I have? U squared. Ooh, that's so much nicer. Minus what?
10u.
10u plus 25. Okay. You can use AC method. You can use trial and error. But I want you to see this. This is 5 squared, isn't it? It's actually a perfect square trinomial. Again, use AC if you want. It's not going to hurt my feelings. It's not going to make any difference. You're going to get the same answer. But this is the perfect square, because we have u that's being squared, I have 5 that's being squared, and in the middle I have 2 times 5 times u. Okay? Now there's one trick to it here. Notice my sign's not quite right. Did y'all see that? Yeah. So I actually need it to be a negative right here. So what I actually need here at the end is I need it to be a negative 5 that's being squared. Jasmine, I think maybe you might want to move closer, because I can't make it any bigger and have enough space on my screen, unfortunately. I'm sorry. So I can blow it up a little bit from where I am, but I'm going to run into the next set of work if I do. Right? See, now I'm running into things. That's what it is on my screen. Haley?
Can u from the 3u to the what else? Can you do the AC method from there?
Yep, you can. Yeah.
Can you show how to do it?
Yep. Let me finish this with the other method, and then we'll do AC on it. Sure.
Okay.
So if I do this with the perfect square trinomial part that we were looking at, there's a 3u to the 5th in front, and then I have u minus 5 and u minus 5. Okay, so that's what it would be. So let me go back and do trial and error with it now. I didn't mean trial and error, I meant AC method, sorry. Okay, all right, so AC means I'm going to multiply A, which is 1, C, which is 25. That's 25. And then B is negative 10. So 25 is either 1 and 25 or 5 and 5. Okay? The sign on when I add them together in the middle is supposed to be negative. So there have to be negatives on everything. So negative 5 and negative 5 is what will do it for me. So if I rewrite, I still have that 3u, is it to the 5th? Yeah, to the 5th in front. Now I have u squared minus 5u plus 25. So 3 to the 5th. And then u squared minus 5u pulls out what? U. And then I've got u minus 5. All right, negative 5u and positive 25 pulls out what? Negative 5. Leaving me with u minus 5. So again, the 3 to the 5th stays the same. The matching parentheses is u minus 5. And then the pieces that remain are another u minus 5. Kenny?
On the other one, so we pulled out the u squared, and then we did the whole like minus 2 times 5 times u in
Yep.
the middle of both of the squares?
Yep.
What happens to all that?
It becomes this at the end. That's what was written down before I erased it. It just becomes that immediately. And the reason it does is because it fits this description of a perfect square trinomial. So I don't have it written. Let me, maybe it would help you to see.
Because I can see why you would just pull the u down, the u squared and the negative 5 squared down, but
You could also write that one out. I didn't write it out that way because I was just assuming B could be negative, but you could write it that way too. So the one that we had the form where I had u squared here, and I had 5 here squared, or negative 5, if you want to think about it that way. And then I have 2 times 5 times u. So it ends up being u minus 5 and u minus 5. Yeah. Okay, one more. Y'all ready? Let's take a look. Whoops. Okay. A little bit too big. Okay. 6y to the 4th, 20y cubed, 14y squared. Surely there's a common factor. What was it? 2? 2y squared. What's it leave me with? Lovely. Even if I wanted to try, this does not fit the perfect cubed trinomial, right? Perfect square trinomial with the squares, right? It's not a difference of squares. So at this point, Haley, on this one, like I'm stuck with the AC method or trial and error. Like I do have to use it. So let's do the AC method on this one, especially because my coefficient on the 3y squared there in the middle is 3. It's not a 1. We'll have more practice again on the AC method. So AC, I have 3 and I have 7. 3 times 7 is 21. My B value is 10. There are only 2 things that 21 could be. It's 1 and 21 or 3 and 7, right? So 21 is a pretty friendly number. I don't have a lot of choices. The other thing that makes this one nice is that my signs are all positive. Also very friendly. So is it 1 and 21 or 3 and 7 that add to 10? 3 and 7. So 3 and 7 are my magic numbers, if you will. So I've still got that 2y squared in front. I have 3y squared minus 3y, plus 3y plus 7y and plus 7 at the end. Okay, so again, the 2y squared stays. What do 3y squared and 3y have in common? 3y. So we'll pull out a 3y, and I'm going to be left with y plus 1. All right, what about 7y and 7? They have a 7 in common. So if I pull out a 7, what am I left with? y plus 1. So again, I have 2y squared in front. The part they have in parentheses in common is what? Y plus 1. You don't actually have to list it first. I just usually look for the common piece first. And then what remains? 3y plus 7. Okay, factoring is one of those things that it's like the more you do it, the more comfortable you get at it. I guarantee. It's kind of like multiplication tables or addition facts, stuff like that. So we still have 10 minutes left. So I'd like for you to go ahead and use that opportunity to get started on this section. It may end up taking you a fair bit this evening. I don't remember how long the homework is. It's only 24 questions, actually, so it's not terribly long. But we only did, give or take 9 in class today. I mean, I used different methods at different points. But this lesson's probably still going to take you the better part of, I would guess, at least an hour, maybe more.
Right?
Okay? Yes, we're on homework 17. So go ahead and grab homework 17 out or open it up on your tablet or your device if you're doing it on a sheet of paper and take a look at homework 17.